Good morning, ladies of calculus. Welcome again to room 15. What happens in room 15?
Learning never ends.
Learning never ends. What about, was anybody able to watch class video yesterday? Stay caught up with anything? We're working on volumes of rotation mainly yesterday. And this is the last one we came up with here. So we're about to the end of this part. We've done about what we could. So we have this thing right here. That's pretty nice ham shape here. Goes like this. And so we're trying to go ahead, and they give us these blanks to fill out. And to me, that's what's pretty helpful about this. You can kind of see what's going on here. So what's going to be so here we have this shape, which is this function here, this 1 plus x square root of x, and it's rotating around the x-axis. And so it has like a template of things to look out for here. So what's going to be our big R, or the outer radius of this thing?
Is this what we did yesterday?
Yeah, this is it. In fact, we drew this yesterday right at the end of class.
It was...
What's our radius of this thing here? Just looking at this, what's going to be our radius? So what this is the square root of x function, but just translated 1 unit up. That's all that is.
What number is this?
Can't find it?
No, what number is that? I can't read it.
So what's our radius for this? What's this? It's going to be the height of this thing here. What's that going to be?
One plus the square root of x.
Okay, 1 plus square root of x. Everybody agree with that? And then it has another thing. It has like little r. Is there a little r here? Like an inside r? No, there's not. So we just have a big R. So what's our volume of this thing going to be? Pi.
0
Okay, we're going from 0 to
to
9.
9.
0 to 9.
Parentheses, 1 plus the square root of x squared.
dx. Is that it? I think that's it. Did you come up with that by yourself? Good job. Yeah. That looks good. And then we can go ahead and if we go ahead, we can let's do a look. We were mainly setting up yesterday, right? We didn't work a lot of these. Let's just go ahead and square this out to just get this a little more meat on this one. So we're going to have between 0 and 9, and we square this out. We're going to have 1 squared we'll have 0 to 9. We'll have 1 squared, which is 1, plus we're going to have 2 square root of x plus x dx. Does everybody see how that, oh, there's pi out front too, right? Everybody see how that happens? The squaring. And then what you have here, just kind of an inset, you're going to have 2 x to the 1/2 power, and what's going to be our integral of 2x to the 1/2 power? Well, it's going to be equal to 2 x to the 3 halves times 2/3. So it's going to be 4/3, right? x to the 3/2. And so now integrating this one here, you have pi, and then you're going to go between, you have just x here, because we have 1x. And here, we're going to have plus 4/3 x to the 3/2, and then we're going to have plus x squared over 2, and then we're going to evaluate between, oops, I meant to take away the sign here. So you're taking away the sign, so you're going like this. And that's pi out front like that. And you're going between 0 and 9. So that's going to be 9, that's going to be 9 to the 3/2, that's going to be 9 squared over 2. So it's going to be a pretty big number once you do all that. But, well, it's just, oh man, okay. Yeah, let's flesh it out to see if we can. I want to see if we get a good calculator check on this deal. So we have 9 plus we have 4/3, and we have that x to the 1/2 power. That's going to be square root of 9, which equals 3, and 3 to the 3rd power equals 27. So that's going to be times 27, and over here plus, that's going to be 81/2 when you substitute in 9. And so 9, that's going to be 9 here. 9 plus 9 plus 40.5. 9 plus 9 plus 40.5. That's going to be 50. 9 plus 9 plus 40.5. 58.5, right? So you should get 58.5 pi. Is what you should get. I don't know. So that's going to be, you got to get approximately 180 out of this deal, I would think. Let's go check this out. So now we try this right here. So we have pi integral from 0 to 9. And we come over here, put in 1 plus 2 square root of x square root of x plus x dx that didn't look the same, because when you had 58, there's something amiss here somehow. I don't know what it is, because that's square root 4/3. Oh yeah, probably times 4 here somehow, because we divided by that times 4, cubed it. Yeah, so you're going to get 4, actually you're going to get 4 times 9 here. So that's going to be 36. So it's going to be 9 plus 36 plus 40.5. So that's going to be 45 plus 40.5, that'll be 85. So you should get 85 pi. Oh, it's a little off somehow. I don't know what happened. There's something that's just 80.5 plus, yeah, Okay, yeah, it's going to be 84. It's going to be 85. Yeah, it'll be 85.5 is what it is. We'll get it right. 85.55 pi. Yeah, there it is. It's good to have these calculators, I'll tell you. Anyway, so we've touched into the cross-sectional areas a little bit. We didn't spend a lot of time at it. But we did spend a lot of time on rotations and setting up and sketching. And I really agree with what Kaylee observed on this, is that really it's the challenge to find out what they are. Now, as it turns out, I do want to go into this one a little bit before we get into the trigonometric ratios, which we're going to get right here. But I want to do this last one here, and this one here, the x-axis, first quadrant region. So we have y equals sine x. And you remember what the sine curve looks like? Well, the sine curve is going to start from negative pi, I think, and go down here like this, then go up like this, and this will be negative pi to positive pi, the first quadrant region, sine, theta, cosine, 0 to pi over 4. Between sine x and cosine x on 0 to pi over 4 is rotated about the x-axis. So y equals cosine x, let's do that. So here's y equals cosine x. So here's our sine x, our cosine x. And here's our sine x. It says the first quadrant region, so we're talking about this piece, aren't we? Actually, we're doing between pi over 4, so we're talking about right here. So we're bounded by that. We're talking about this piece right here. Is that where it's bounded? And we're rotating about on 0, that's, wait a second, 0 to pi over 4. That's, okay, this is pi over 2, pi over 4, 3 pi over 4. So pi over 4 is going to be right here. So we're going to go between 0 and pi over 4, and we're going to have it's going to be this area here, isn't it? Okay, so we're taking this area here and rotating around this way. So what's going to be for this one right here? I got this cosine one. We're taking this one, rotating it around. So what's our big R going to be? Cosine x or sine x? What's our big R? The cosine, right? Looks like it's going to be right here. So we're going to call big R cosine x. And little r is going to be our sine x. And our volume is going to be integral from 0 to pi over 4. And then we're rotating, so we have pi. And so we're going to take this cosine squared x minus sine squared x dx. This would be our volume. what's the integral of cosine x? And what's the integral of sine x? Let's do the snow cone Santa Claus. So we got minus minus. So if we derive, we're going this way, right? Derivative, derivative, derivative. But in integrate, we go which way? This way. So what's our integral of sine? Negative cosine. It was negative cosine x. And our integral of cosine x is going to be sine x. And then, just to piece it out a little more, if we have integral of, what's the integral of cosine squared x? Well, if you take cosine x and square it. Now you can do this a bunch of different ways. Probably, to me, the easiest way to do this is take a u substitution. So if we let u equal cosine x, then du is equal to cosine sine x dx. So dx is equal to du over sine x. And you know something, I just don't, and then we can go in here and we take this integral of this thing right here, and to me, you can do it, but I don't want to do it other than that right now, because that's too much. So basically, you set it up like this, and that's going to be your answer, okay? But again, you have to sketch it, look at it. It's not the easiest thing in the world, but that's that, really. So what we're going to do is the way this packet is designed, we've kind of gone through the polynomial functions pretty much, and we're cycling back through with this packet stuff here, the trigonometry. So it's taken a second pass at this. And basically, this is a sketch that reviews our unit circle of trigonometry. Do any of you still have your unit circles from last year? No, you don't have those. But here's a little sketch of it. And the identities, in pre-calculus and calculus, the main identities we use aren't these. If you get into college pre-calculus, you might do these identities here on the right, but the ones we really hang our hat on in pre-calculus and calculus are these ones right here. These two on top and this one on the side. Pythagorean identity. Yeah, we're doing that a lot this year in actual pre-calculus. We didn't do very much last year when you took pre-calculus. Anyway, unwrapping graphs of sine and cosine. And to me, what's helpful about this thing here is when you go to a calculator and you enter something, you may not know what it is, but if you see this thing right here, that means it's square root of 3 over 2. So if you just recognize what decimals approach that. So the square root of 2 over 2 is going to be 0.707. Square root of 3 over 2 is 0.866. So just something to look out for. Another thing that you come across too, it doesn't say here, but the square root of 3 is 1. You get 1.7 something. Yeah, 1.732. So just some numbers whose decimals you might come across. And if you just remember those things, that can help you. Oh, another thing on these that makes your life easier, I'll show you this, if you have a chance to do it, is when it comes to sine and cosine, the multiples of pi over 2 will just give you 0 or 1 or negative 1. That's all they give you. Say over here, 0, 1, 0, negative 1, 0, 1. Okay, sines will be 0, 1, 0, negative 1, 0. So when you see problems with those about pi, pi over 2, 2 pi, 3 pi over 2, it's all going to be just ones and zeros and negative ones. So you'll see that quite a bit in those exercises. But basically what you're being held to as far as what the intention of the course is to make you responsible for all these values inside a 16-point unit circle. And we talked about the hand trick last year, didn't we? We did some of that, and basically it's okay, fingers above, fingers below. Here's your sine are going to be square root of fingers below over 2. Cosine is square root of fingers above over 2. Your tangent is going to be square root of fingers over square root of fingers. And I had we have it right here on our unit circle mug. Did we used this before, didn't we? Thought we used it. So Emily, when you go to Baylor, are they going to give you a test like an Alex or something to see where you start out in math? Do you know when you take it?
Like that and chemistry and all that.
But they'll give you, or you're going to take that later, an Alex test?
I can take it right now.
You can take it now? Okay. But you have to take it, right? So you get properly inserted.
Hello, Mr. G. I hate to interrupt your class, but I have something for you.
Now, does this person, thank you, does this person look like does she look like she hates to do that? She's saying she hates to do it, but she's smiling when she comes in here.
Yeah.
Thank you. Well, thanks for being considerate. See, look at this. Thank you. What do you think's in here?
Chocolate.
That's my guess too.
An April Fool's thing.
Oh yeah, it could be April Fool's. I bet it is. Yeah. No, unless this is full of air. That's a little snooty thing. Okay. Well, that was really nice of her not to bring April Fool's stuff in here. She could have done that and got away with it today, right? Yeah, really nice. Okay, evaluate each of the following. So basically this is an exercise set of put away the unit circle. Can you do these? Can you evaluate these without using the unit circle? And the way I tell the pre-calculus students to do these is see if you can test these out by yourself using a hand trick, and then you can use your unit circle to check. And you have that unit circle on that page, right? So you can check it. So I want you to see if you can do those. And we'll go over those in a couple minutes. Yeah, that's good. Yeah, they should all be doable. Yeah, so go do these 1 through. Okay, that's the way I have them ordered, okay. The way I cut them out is I cut out this thing here. So the next thing would be 3, 4, 12, 13, right? Yeah, 3, 4, 12, 13. So you just kind of go on the left column. 1, 2, 3, 4, 5, 6. Yeah, and then there's 9. Yeah. So go down to 9 on the left. We'll go over these in a few minutes, okay? See if you can test that. I mean, I already know like 2, that's going to be square root of 2 over 2. I know that one. I know this one's going to be same. The tangents are going to be a little harder to figure out. But it's going to be square root of fingers over square root of fingers. So square root of these fingers over square root of these fingers. That's what that's going to be. Do you find you're able to do these without looking at the unit circle? Some of them, yeah. To me, it's helpful. This is the example. This is really, we are, and Hannah could probably testify of this. We are a very right-handed centric society, aren't we? Do you notice that? So things that are designed for right-handed people, including the hand trick. Because what Hannah has to do, she has to go look at her left hand, then take that same left hand and write with it, while the rest of us, we can just take our right hand. And we don't have to, when we write, we don't smudge over our hand while we write. Do you smudge over your hand when you write? But curiously, some of the best YouTube people who do things like I do are left-handed. So probably for today, I think what we do is let's just get through these exercises. Let me see what we have after this. Yeah, because I think the next one is the note card. Yeah, so we'll get note card 54. So we're going to do analytic strategies. We'll look at that tomorrow. Let's take... see where that is. That's going to be 825. Okay, tangent. Let's go, I want to go down here. I want to do them in order somewhat. So 3 and 4. Sine pi over 2. That's going to be 1. Tangent of 4 pi over 3. So that's going to be like a reference angle of pi over 3. So it's going to be negative square root of 3. No, it's not. This is going to be that's wrong, because that's going to be quadrant 3. That's going to be positive. It'll be down here. So 4 pi over 3 is going to be right down here like this. So you're going to have, that's going to be positive because you have negative divided by negative. This one here is going to be square root of 3 over 2. How did I know that? You're going to circle trigonometry song. The x's are 1 square root of 3 over 2. Horizontal angles be square root of 2 over 2, next to 1 half and 0 to the statement again. This one here, you have the sine of 7 pi over 4, it's going to be right here. So you're going to have negative square root of 2 over 2. Cosine 2 pi over 3, that's going to be right over here. That's going to be negative 1/2. Here you have sine over cosine. Sine is 0 over negative 1. 0 over negative 1 is 0. Cosine 3 over pi over 2, that's going to be 0. This one's going to be negative square root of 2 over 2. Here we're going to have 3 pi over 4 is over here. So that's going to be like square root of these fingers, so we get 1, but negative 1 is over there in quadrant 2. Cosine of this, that's going to be over here this way, so it's negative. This one here, 16. 5 pi over 3 is going to be right down here like this. So your reference angle is going to be like pi over 3, but it's going to be negative because we're down here. So that's going to be pi over 3. That's going to be square root of, that's going to be square root of 3 over 2. But we're down this way, so we have negative square root of 3 over 2. And tangent 3 pi over 2, that's going to be undefined. Undefined. Dividing by 0, that's what you're doing, dividing by 0 there. So just what should be kind of a little bit of review of what these things are. 11 pi over 6, that's going to be, your reference angle is going to be pi over 6. Because you have this 11 pi over 6 right here. So here's your reference angle. So your reference angle is going to be pi over 6, but that's going to be negative. But you have this, you have square root of little finger, which is square root of 1 over 2. That's going to be negative 1/2. And cosine of 3 pi over 4, that's going to be over this way. So negative square root of 2 over 2. So this is supposed to be just a review of those things. Does that make sense? Did I get any of these wrong?
You go back to the number 5, 6, 14.
So this note card here,
She was talking about
Number 5.
well, number 5. Yeah, we have, on this one, what we have is we have 2 pi over 3 is right here. So here's pi over 3 over here, and here's 2 pi over 3, but our reference angle is going to be right here like this, but cosine is going to be negative. So what we have here is we're going to have, it's going to be like this, square root of this finger over 2, so square root of 1 over 2, but that's going to be negative because we're over here in quadrant 2. That's how we got the negative 1/2.